This concavity problem takes a lot more works compared to the others. Let's get started. The function is f of x equals to x divided by x squared minus 1. So I gave you the factor form. The reason is I would like to point out the domain. So look at the factor form. So this one domain x cannot be equal to -1 and 1, right? Because we don't want to have a 0 in the denominator. And then we will follow this procedure. So first find the f prime and f double prime. So for prime and double prime, you have to use the quotient rule. So here is the quotient rule. Let's do the f prime. So f prime of x. So we have a g square, right? So I will square this immediately. X squared minus 1, I will square immediately. And then the top, that is x squared minus 1. F prime, the derivative of the top is equals to 1 minus fg prime. So f is x. And then the derivative of the bottom is equals to 2x. And then this gives me x squared minus 1 and then minus 2x squared, right? Minus 2x squared divided by x squared minus 1 squared. So overall, f prime of x, that is equals to negative x squared minus 1 divided by x squared minus 1 squared. Nothing can be simplified, okay? Don't even think about it. We are going to start the double prime right now. So double prime. So the bottom is the square of the square. So therefore, I'm going to prepare a long fraction bar first. And then x squared minus 1. So you square the square. So that gives you a fourth power, right? Down there. And then the top, we follow g. So g is x squared minus 1 square. G f prime, the derivative of the top is negative 2x. And then minus for the quotient rule, and then f is negative x squared minus 1, and then g prime is, so g prime you have to use the chain rule, so you bring the 2 down, and then x squared minus 1, the second power becomes first, and then you take the derivative of the x squared minus 1, so you have a 2x. So this one I'm going to do some works on the right, so therefore I'm going to take this I'm going to take this line and then move a little bit to the left, so that's save some space for myself. So move a little bit to the left. All right, that's good. And then next step, clean up the top, double prime. Okay, so we have negative 2x times x squared minus 1 square. And then the other side looks like we have a 4x at front. And then negative x squared minus 1 times x squared minus 1 divided by the fourth power, x squared minus 1 to the fourth power. So let's double check. Negative 2x, x squared minus 1 square, 4x, negative x squared minus 1, and then x squared minus 1. And then the next step is I am going to break this down into two big fractions. So double prime, that is equals to negative 2x and then x squared minus 1 square divided by the fourth power, x squared minus 1 fourth power. See, there are some cancellations. And then minus 4x, negative x squared minus 1. We have a x squared minus 1 divided by the fourth power, x squared minus 1 to the fourth. And then just let you know that this minus goes right over here. All right, so that's the minus. And then now let's do some simplification. Okay, this is gone, right? And then this 4 minus 2 becomes a second power. And then this is gone. 4 minus 1 becomes a third power. And then in the next step, I am going to do a common denominator. So let's move on to the next step. So next step, double prime. That is equals to negative 2x divided by x squared minus 1 square, and then let's save some space. We have a 4x times negative x squared minus 1. You know what? Let's just distribute. We have a minus, right? Minus fraction bar. Negative 4x to the third, right? Minus 4x divided by x squared minus 1 to the third. So compare the denominator. So I need one more x minus 1 for the first fraction. That's what I'm going to do. I'm going to multiply the top and bottom by x minus 1 and then x minus 1. I mean x squared minus 1. That doesn't look like a 2, right? 2, 2. Okay, now you are happy. Next, distribute the red and the yellow. Double prime. And then the other one is also a distribution. So let's just do this. That looks clear, right? So now we have a negative 2x to the third plus 2x plus 4x to the third plus 4x. You distribute the big minus to each of the term inside the red parenthesis. And then in the denominator, we have x squared minus 1 to the third power. So overall, what do we have for the second power? The second power, we have, okay, let's take a look at the space. So we have f double prime. Negative 2 plus 4 is equals to 2. We have 2x to the third plus 6x. And then the denominator is x squared minus 1 to the third. And then since this is a second derivative, we have to set that equals to 0 and then solve for x. Before we set that equals to 0, let's factor our 2x. So we have a x plus 3, square plus 3, divided by x squared minus 1 to the third, and then you have to set that equals to 0. Why do we have to set that equals to 0? Because this is a second derivative. Second derivative, you set that equals to 0, you find the critical points. Those critical points can be inflection point. To prove it is inflection point, you have to do a Sine chart. So you have a top divided by a bottom equals to 0. So that brings us back to simple math, right? A divided by B equals to 0. So we know that B cannot be equal to 0. Therefore, we just force A to be equal to 0, right? So that gives me a 2x times x squared plus 3 equals to 0. So we have x equals to 0. And then how about the other one? Can x squared plus 3 equals to 0? This one has no solution, right? So therefore, we have one critical number, that is x equals to 0. So this is my only critical number. X squared plus 3, you square a number. Even though you pick 0, you square a number, you add 3 to it, you never get a 0. Besides, if you look at the graph, this is a parabola shift 3 units up. So the vertex is at 0, 3. The parabola will never cross the x-axis, so therefore y will never be equal to 0. So x equals to 0 is your only inflection point. All right, so x equals to 0. So now the next step is we will do a Sine chart. So Sine chart, let's go back up. So for the Sine chart, let's use a different colors. What should I use? Let's use red, or I should use purple. So for Sine chart, we have to find the test interval first. So for the test interval, you have negative 1, 1, and 0. So one line, 3 cut, negative 1, 0, and then 1, right? So that gives you 3 cuts from negative infinity to negative 1, negative 1 to 0, 0 to 1, and then from 1 to positive infinity. And then you have a Sine chart. This one, let's save some space. So if with some practice, you can just do it right here. So the next thing that you will have to pick is you pick a test value. So this one, I pick x equals to negative 2, x equals to negative 0.5, and then x equals to positive 0.5, and pick x equals to 2. And then you have to test. So these are the test intervals. And then you test f double prime of x. Right? So this is f double prime of negative 2, f double prime of negative 0.5, and then f double prime of 0.5, and then f double prime of 2. So all you have to do is you plug in the double prime to here, right? So here is your double prime. Let's copy this. Not cut. Let's copy this. Why do I cut this every single time? So let's, okay, copy, got it. Paste, so this is your f double prime. F double prime of x. So when x is equals to 2, you have f double prime. You have f double prime of 2. So you have 2 times 2, and then 2 squared plus 3 divided by 2 squared minus 1 to the third. So that gives me 1.037, and then you do this for the other three numbers. So at the end of the day, I have negative 1.037, 7.704, and then this is negative 7.704, and then this is 1.037. And then positive double prime, what does that mean? Positive double prime means concave up, right? Negative double prime means concave down. Positive double prime means concave up, and then this is concave down. So we have down, up, down, up. Okay, let's move this to down because I'm about to draw a conclusion. Okay, this is concave down, this is concave up, this is concave down, and then this is concave up. When you do homeworks online or on paper, they will ask you the interval where that is concave up and concave down. So where is the interval? This interval is from negative infinity to negative 1, right? Just look up. This is a negative 1 to 0, and then this is 0 to 1, and then this is from 1 to positive infinity. Okay, and then they ask you to find the inflection point, and then here is the next thing that you have to be careful. So this x equals to a negative 1. This is a vertical asymptote, right? This x equals to 1, so that is also a vertical asymptote. They are not the critical points. Do you see that? At the very beginning, x cannot be equal to 1 and negative 1 because they are vertical asymptotes. So the only critical point is where x equals to 0. All right, so where x equals to 0. Let's move this one more time. Actually, I'm going to shrink this and then just put it right here so I can draw my conclusion. So that means x equals to 0 is my vertical asymptote, right? So sorry, x equals to 0. So this is my inflection point at x equals to 0, and then to find out the y coordinate, you plug this into the function f. So when x equals to 0, what do we have? We have 0 divided by 0 squared minus 1, so that is equals to 0. So this is just equals to 0. So that is equals to 0, and therefore 0 comma 0 is the point where the concavity changes. Okay, so overall, let's take a look at the graph. So we have 0, 0 as the inflection point. That makes sense. So 0, 0, that is my inflection point. And then this is what do we have? We have down, up, down, up. So from negative infinity to negative 1. So this is negative 1. So this is concave down. And then this is concave up. And then this is concave down. And then this is concave down. And then this is where the up and down changes. And then unfortunately, when x equals to 1 and negative 1, we have a vertical asymptote. I can also draw that for you. So there is a vertical asymptote right over here. And then right over here. They are the vertical asymptote. So they cannot be inflection point. Okay, so even though that is the concavity changes, vertical asymptote, nothing is defined over there. Okay, so that is the end of this video. It's a very challenging problem, but after you solve it, I am feeling very rewarding and very worth it. Okay, so if you think my instruction is clear and helpful, give me a like, share this video in any social media for me, especially Facebook. If you are new to the channel, please spend 2 seconds to click the subscribe button down below. I appreciate your help and subscription. I will see you all in the next one. Signing out.